Okay, so today we will discuss on introduction to matrix and Gaussian elimination process. It's all about the equations and its unknowns and finding out the unknowns and various process of finding the unknowns and with the elimination methods, the different elimination methods and the matrix method that we're going to see. Now let us switch to screen here. So here the objective is to find the unknowns. When the number of unknowns equals the number of equations, we have n equations in n unknowns. So let me write this statement here. So it states that when the number of unknowns equals the number of equations, then we have n equations in n unknowns. So I'll take a small example here. So I'll take an example of n equal to 2. We'll take the two equations here, that is 1x plus 2y is equal to 3 and 4x plus 5y is equal to 6. So we have two equations here and two unknowns. We have two equations and two unknowns in these equations. So here we can find out these unknown values, that is the value of x and y, in two methods. So one is by elimination method and another one is by determinant method, and we will see which one is better. This is unknowns. So we'll take the elimination method first here. So let's talk about you all know how to do this elimination method. So to do the elimination method, we will look into the first equation here. So we will multiply the first equation with 4 and then subtract this by equation 2. So let's see what do we get here. So then we'll take the first equation. Okay, so let me multiply 4 with the first equation here. That is 1x plus 2y is equal to, let us revise even if you know, because we want to relate here the determinants and elimination, how it is related and which is better to them. So this is 3. So we know this is equal to, this is 4x plus 2y, 4x plus 8y equal to 12. And now let us subtract this by the second equation. Yes, so here the second equation is 4x plus 5y equal to 6, and the first equation, which is multiplied by 4 or 4 times the equation 1, so we will get 4x plus 8y equal to 12. Now we will going to subtract this by changing the signs. So change the sign and subtract. So what do we get? So x gets cancelled here, and here we get this as minus 3y equal to minus 6. So therefore we will get y is equal to 2. And then when we substitute this 2 in first equation, we'll get, so this is called back substitution method. So far whatever we have done, it is the forward method, forward substitution method, because we have eliminated, it is the elimination process. Now it is a back substitution method. So let me write here. So back substitution is nothing but in the first equation we are going to substitute the value of y. So then we have 1x plus 2 into 2 equal to 3. So then we will get a value of x is equal to minus 1. So this is how we can find the value of x and y with the help of um, elimination process. So here what we have done, we applied a simple method. So what we have done, that is 4 times the equation 1, we have multiplied the 4 times the equation 1 and then subtracted this with equation 2. So this is a method we have used. Now let us see the same thing with the determinants. So determinants, the ratio of determinants, and let us write for y here first. Let me clear this or save me this section. So let us see the determinant section. Let me write the equations again so that we can understand. So the equations are 1x plus 2y is equal to 3, and this is 4x plus 5y is equal to 6. So now if you want to find for y with the determinant method, so then that can be written as, so we'll take out this and we'll write only the coefficients of this x and the right hand side. So then we have here 1, 3, 4 and 6 divided by the coefficients on the left hand side. So that is 1, 2, 4 and 5. So then it is just the cross multiplication of this. So then we have, that is 1 into 6 minus 3 into 4 divide by, it is 1 into 5 minus 2 into 4. So basically we will get the same thing here, that is minus 6 by minus 3 equal to 2. So now let us look into the finding of another term here, unknown, that is x. So now x can be obtained as the coefficient of y with right hand side. So that is 3. Yeah. So it is 3, 2, 6, 5 divide by, it is the coefficient on the left side, that is 1, 2, 4, 5. So then cross multiply this, so you will get 3 into 5 minus 2 into 6 divide by 1 into 5 minus 2 into 4. So we'll get this as 3 by minus 3, which is equal to minus 1, right? So this is fine. So I know that you know this process of the basic elimination and determinants. So here we just want to compare it. Now here how many equations we have? We have 2 equations. And how many unknowns? 2 unknowns. If there's, say, there's number of equations become 1000. Can you imagine? There are 1000 unknowns and 1000 equations. Can we go for this method, determinant method? It is very difficult, or it is not at all possible to apply the determinant method in such case. So then the best method, we have to go for Gaussian elimination process or the Gaussian elimination algorithm. So that we will see later. So here we want to highlight a few points here before going into detail of this topic. So as I told, if the value of n, the n nothing but the number of equations, so n defines the number of equations. If for example if the n becomes 1000, then determinant method is not a real time method to solve this. So then we have to go for the other method, that is Gaussian elimination algorithm. Okay, so here when we see that, then the elimination process is dominating on the discriminant method, and we look into this. So the idea of elimination is deceptively simple here. So the mechanism of the algorithm we will put like this in 4 different points. So let me go to the next page and save this. So we want to just put across the algorithm process here. So then we will look into each of these concepts. So the first one is the linear equation leads to geometry of planes. So this is the first point. The linear equation leads to geometry of the plane. It is not easy to visualize. For example, if we talk about say uh, two equations, it is fine. It means we have two unknowns, or that is x and y, then we can plot it on the 2 dimension. But if we have the n dimensions, or if we have the 9 dimensions, it's very difficult to imagine how does it looks like. Then it is hard to see 10 of these planes and intersecting. So basically here we are talking about the intersection of, for example, we have the two axes here, that is x and y, and the same previous equation, if we take, for example, if I take, so x plus 2y equal to 3, x plus 2y equal to 3, and we have second equation, that is here the 4x plus 5y equal to 6. So x plus 2y equal to 3 and 4x plus 5y equal to 6. Now if you plot this, we know the value of x is -1 and y is 2, we got from the previous method that we have found. Now if we plot this, so it will be something like this, a straight line. So x plus 2y equal to 3 will give us a straight line, and 4x plus 5 also gives a straight line, and this point of intersection will define our the solution here. So this intersection point is nothing but that is -1 and 2. So -1 is x and 2 is the y value, so which we are trying to find. So like this is okay for a 2-dimension case. If the number of unknowns and the equations increases, say 9, then it is very difficult to imagine this 9 dimension. So that is why we go with the linear equation leads to the geometry of the plane. So that is what it is telling. So let me clear this section here. So then the second point is we move to matrix notations by writing the n unknowns as a vector x, and the n equations as ax equal to b. So ax equal to b is nothing but, so here we are going for, so that is why we will go for, we do not keep this in the equation method, we will move these equations to a matrix form, and then we will try to represent these in terms of vectors, and n equations are represented as ax equal to b. So here x represents the unknowns and a is the coefficients of these equations, and the b is the right hand side of this. Now for example, in the previous equations, that is nothing but we had, that is x plus 2y equal to 3 and 4x plus 5y is equal to 6. So this, we have this equation here, x plus 2y equal to 3 and 4x plus 5y equal to 6. We have the two equations and two unknowns. Now this can be written in Ax equal to B form. That is, in terms of matrix, this is 1, 2, we'll write the coefficients here, and this is 4 and 5. So this is a 2 cross 2 matrix, and we'll write in terms of vector for the unknowns, so that is x and y. So this represents a vector, and this is equal to another vector on the right hand side, so that is 3 and 6. So this is nothing but A into x equal to B. So this is what we are talking about, and we multiply A by elimination matrix to reach the upper triangle matrix, that is U. So U is another term or the another kind of matrix that we'll use here. So that is a kind of a matrix which has the upper matrix. For example, if we have, say, some numbers here, 5 minus 2 4, then 3 6, here 0 and 1. So this kind of matrix, we call it as upper matrix, because we have the coefficients only in the upper diagonal and the upper to the diagonal, and below the values, below the diagonal values, it is 0. So this kind of matrix, we call it as upper matrix. So we are going to multiply the A by elimination matrix to reach the upper triangle matrix U, and those steps factor into L times U, where L is the lower matrix. Means the reverse of this is the L matrix. For example, if you want to write the L matrix, then the coefficients will be exist diagonal and below the diagonal. So this might be minus 2 and 3, then here it is 4, and this is 5, and this might be 6, and these values are 0. So this kind of matrix, we call it as the lower matrix, where L is the lower matrix, and we are going to factorize A in terms of upper matrix and lower matrix. So let us see that how, and before that, let me complete the statement here. So it says that we multiply A by elimination matrices to reach an upper triangular matrix U, triangular matrix U. So those steps are factorize. So those steps factor A into L times U. So where L is the lower matrix. So let us see an example for this case. So I'll take out this terms. So now, for example, we have A as a matrix, that is the coefficient, say 1, 2, 4 and 5. So then we can also obtain this with the L times the upper matrix. That means I can write this as 1, 4, 1, 0. So now this is the lower matrix into the upper matrix is 1, 2, 0, minus 3. So these are written by to obtain this. It is not obtained from something. It is managed to return these matrices, that is, this is L and this is U, so that we can obtain A. Now just multiply this, what do we get? We'll get back this A matrix itself. So this is the lower matrix here, this is the upper matrix, and this is the lower matrix. So now if you multiply this, what do we get here? So this 1, and then here we'll get here 2. So now if you multiply this 4 times this first vector, that is 4, and then you multiply this, we'll get here, that is 2 minus, so we'll get, that is, we'll get here 8 minus 3, so that is nothing but we'll get back here 5. So 1, 2, 4, and this is 5. So it means we can factorize the A as the lower matrix and upper matrix. So that is what we meant here. Alright, so now I'll take out this and I'll go to the next point. So the next point is the third point. So in most cases the elimination goes forward without difficulties, but at some point it will break down. So then we have to go for a different method. So in such cases what happens, there may not be any solution, or there might be infinite number of solutions. So that is what it is talking about. So in most cases elimination goes forward. Elimination goes forward without difficulties, and the matrix has the inverse, that is Ax equal to B has one solution. Uh, at some exceptional cases, in exceptional cases, the method will break down. Either the equations were, so the reason for that, the equations were taken in a wrong order, which is easily fixed by exchanging them, or the equation do not have the unique solution. For example, now if we take a same example as before, that is 1x plus 2y equal to 3, and we had one more equation, that is 4x plus 5y equal to 6. So now here in the second equation, if this coefficient is replaced by 8, that is 5 is replaced by 8, then what happens? So 1x plus 2y equal to 3, and 4x plus 8y equal to 6. Now if we try to simplify this equation, now let us multiply this by 4, the first equation by 4, and subtract the second equation. So what do we get here? Let us write this as 4x plus 8y equal to 0, and the second equation will the first equation multiplied by 4, so we'll got this 4x plus 8y equal to here we'll get this as 12. So now when we subtract this, what happened? So both the unknown terms will get cancelled, so we have 0, which is equal to minus 6. It means there is no solution at all. So in this case what happens, the equations are not properly written, or it might be possibility that there might be infinite number of solutions. So this is another case. So let me clear this again. So let me go to the fourth point here. So we need a rough count of number of elimination steps, because whenever we are computing in a system, so the number of multiplications and subtractions, uh, for example, if there are the millions of steps, then it might be take uh, sorry if there are hundreds of equations, then it may take million steps in terms of multiplication and subtraction. But when the number of equations again increase, then it will become very difficult, and there are a round of errors as well. So let me put in statement here. We need a rough count of the number of elimination steps required to solve a system of size n, because the computing cost often determines the accuracy in the model. So as I said, the 100 equations requires a third of a million steps, which is nothing but multiplication and subtraction, and the computer can quickly do this, but may not do with the trillions of steps. Okay, so these are the points which we are going to discuss throughout this module, which is carry forward. This is actually the basics for this module, which is very much required. Okay, so let me save this page. So now we will talk on the geometry of linear equations. Let us take an example of two equations here. So we have taken the two equations, that is 2x minus y equal to 1 and x plus y equal to 5. So here if we look into these equations and we try to solve this, we will get the value of x and y as 2 and 3. So let us find with the elimination process. We know how to find it. So we'll multiply the equation 2 with 2, or we can also just subtract this as it is without any multiplying factor. So then we are going to eliminate y, and we have x equal to minus 4. No, I think it's not right. No, no, I think there is something wrong. So let us multiply this equation 2 with 2 and then subtract with equation 1. So it is minus y equal to 1, and then we have the 2x plus 2y equal to 10, and when we subtract this will get cancelled. So we have here we get here y equal to minus 9. Is that correct? I think something is wrong here. X plus y is equal to 5. Can anybody tell me what is the answer for x and y for this case? Because here it's telling the point it is 2 and 3. So if you just go with this method and subtract. So get this, we get x equals minus 4. X equal to 2. How is that? And anybody wants to talk here? And y is equal to 3. Exactly. I just want to know how do you get this x equal to 2 and y equal to 3. Because when I'm trying to do this, I'm getting x is equal to minus 4. Okay. So when I cancel y, I get x is equal to minus 4. Without change. Okay, right. Without changing the sign. Okay, so we'll cancel here. So we'll get what do we get here? 3x. Right. So 3x equal to, we'll get 6, so therefore yes, so we'll get x equal to 2, and then when we back substitute this, we will get y is equal to 3. Okay, so it means if we plot this in a plane, when you plot this on a plane, we have the terms here. Now for example, if we take that this is your y and this is the x, so in this first equation, so let me write the equation separately here again. So that is 2x minus y equal to 1 and x plus y equal to 5. So in the second equation, if you make x equal to 0 and y as 5, so that will become 5. So we have the point here, so this is nothing but this point is 0 comma 5, and then we get a line like this, and this is another point where x is equal to 5 and y is 0, so that is equal to the right hand side, so we'll get this can be written as 5 comma 0. So likewise, so if we extend this, so here we get one more line. So this is equation where for the first equation, that is 2x minus y is equal to 1. In that equation, if we make y is equal to minus 1 and x equal to 0, so then it means it is equal to the right hand side. So this is 0 and this is minus 1, and then the other point like this, if we continue, so it meets at one point. This is our x and y, which is equal to, that is nothing but 2 comma 3. So this equation is 2x minus y equal to 1, and this equation is x plus y equal to 5. So same thing also we can represent in terms of the column form, in terms of column picture. So let me save this and take to the, so before saving, let me take out this unnecessary things. So this can also be represented in a column form, in a one vector equation form. That is the first approach. That is the elimination approach was the first one. Now the second approach is the one vector equation or the column of linear equations. Now the same equation, for example, we had the equation that is 2x minus y equal to 1, and that is x plus y equal to 5. So we have this two equation form here. So now that can be written in a column form as x with a vector, that is 2 and 1. So 2 and 1 are the coefficients here. This is 2 and this is the one coefficient of x, plus y with minus 1 and plus 1, and the right hand side, that is 1 and 5. So it can be written in this column form, and the column picture, if you write here, so then it will look something like this. So x and y, this is in terms of x and y. Sorry, it's not x and y, it is the columns actually. Yes, it is x and y, sorry, it is x and y. So now we will take the first vector here. So 2 so the 2 point, it is not x and y actually, let us write like this. There are two axes, so the this vertical axis represents the 2 and 1. It means we will get this vector somewhere here. So this is your 2 comma 1, that is the column 1, and this is the minus 1. It just look like this, just consider this as the quadrant. This is first quadrant, second quadrant, likewise. So minus 1 and 1 means, so x-axis is minus 1 and y the another axis. Don't confuse this y with the y which I'm telling. So these y's are actually unknowns. So then it is minus 1 and 1, it means we'll get in this side. So this is nothing but this is a column 2, so this 1 and minus 1 here. Then to get this, to find the combination of the column vector on the left side that produces the right side. To get this, what we will do, we'll reach at the point, we'll multiply this second column with 3. So what do we get here when you multiply with this 3? So we'll get one more point here, that is at minus 3 and 3. So what we did, we have multiplied this column, so this is our column 2. So we multiplied the column 2 with 3, we got this point. And then when we add this column 1 and this one, that means when we take the 2 times, let us multiply this column 1 also with 2. So what do we get here? So we'll get the one more point here, so that is nothing but 4 comma 2. So 2 times the column 1, we get this, plus now 3 times the column 2, then what do we get? Now it means we have to add this term with this. So what we get here, so we will reach, so minus 3 plus 4, we will get 1. So 1 might be here in the first quadrant. So then 3 and plus 2, we'll get 5. So 5 means we have the point in the first quadrant, so we'll get somewhere here. So we will get this here. So finally we will get this answer as 1 comma 5. So this is another method of representing this. So this is the column form. So okay, we will wind up this, and in the next example we'll take this for the 2 planes example. So next we'll take the 3 planes and we'll try to understand that. So like this we'll discuss in the next classes about the basics of this.